In this video, we are going to talk about solving compound inequalities. So basically, the idea behind a compound inequality is that there are two inequalities within the inequality statements. So we are supposed to solve, graph, and write our answer in interval notation. So the best way to look at this, and let me give you some background just before we get started. There are two main types of compound inequalities. They are either going to be what we refer to as like an and or an or. All right, so with an and statement, your answer needs to satisfy both inequalities. Okay, so it has to belong to both. Your final answer will belong to both. The or is just simply it needs to satisfy either or inequality. So the answer here needs to satisfy the inequalities. Okay, so we're going to take a look at what that means. The and is the one that you have to be particularly careful of. All right, so when you have a compound inequalities, one of the best techniques is to break it up. There are two hidden within here. Here is one inequality that we will rewrite separately. And the other inequality is this one. So 2x plus 2 is less than 6. So now when we've broken them up, we can go ahead and solve them as normal. So like if I were to subtract 2, I would get 1 is less than or equal to 2x. I would divide by 2, and I get 1/2 is less than or equal to x. Now, in using the reversal property, I would like to have the x on the left, but then I would have to make sure that it is pointing to the original number. All right, so these two are the same thing. So let's go ahead and subtract 2 to this side. We get 2x is less than 4, so we get x is less than 2. So what this is saying is that on a number line, you have 1/2, and then you also have 2. Now x is bigger than 1/2 and equal to, so we're going this direction, and x is less than 2. Okay, so now we're going here and we're going in this direction. So remember that when you have a compound, you have to figure out if you have an and or an or. And so what's really nice about this, if it's an or, it's going to tell you it's an or. So this would be an and type of statement, and the answer needs to satisfy both inequalities. So the question is, where is the overlap? And so you should be able to see that there's overlap from here and here. So what we have is we have our smallest answer is 1/2. Our largest number is 2. We are not including the 2 because if we include the 2, it wouldn't work into this statement. So we have to have parentheses here. We can include the 1/2 because it is a part of this solution set, and it is also a closed bracket from the original one, or the closed circle from the original one. So that would be our graph. This would be solving, and then this would be our answer in interval notation. All right, let's take a look at number 2. So again, we want to see that there are two different inequalities here. So 3 plus x is greater than 7x minus 2. And then we also have the 7x minus 2 on this side. So 7x minus 2 is greater than 5x minus 10. All right, so now what we have is we are going to maybe, subtract 7x. So I get 3 minus 6x is greater than negative 2. Subtract 3. So we have negative 6x is greater than negative 5. Divide by negative 6. So I get x, we got to flip the sign, is less than 5 over 6. Now let's take a look at this one here. Subtract 5x. We've got 2x minus 2 is greater than negative 10. Add 2. 2x is greater than negative 8. So x is greater than negative 4. Okay, so let's take a look on what that looks like on our number line. So if we had a number line, smallest number is here, negative 4. 5, 6 is right here. X is smaller than 5, 6. X is bigger than negative 4. And notice that there's an overlap. The overlap is right here. So in interval notation, the smallest number is negative 4. The smallest number is negative 4. The largest number is 5, 6. You cannot include either of them because this doesn't have an equal to. They're both open circles. All right, so now let's take a look at number 3. What's nice about this is it's already set up as an OR. And now we just go ahead and solve. 2x is less than, add 5 to both sides. You get negative 6. X is less than negative 3. Subtract 1. 5x is greater than or equal to 5. X is greater than or equal to 1. So on a number line, again, negative 3, 1. Open to the left. 1 is closed to the right. So that's what our graph would be. This would be what our solution would be. This is our graph, and then we now need interval notation. So there are 2 separate graphs on here. So that kind of takes us to where we have 2 separate intervals. So the first one, always go from least to greatest. So negative infinity to negative 3, union, pick back up at 1, which I'm having as a bracket because it's closed, and then parentheses.